Hello, everybody. We're going to do something a little different today than what we've been doing in the past. Instead of taking derivatives, we're going to do a different thing called antiderivatives. So suppose for a moment I told you that f prime of x was equal to 3x squared. And the question I'm going to actually ask you is, what is f of x? In other words, this time, instead of giving you a function and asking you to take the derivative, I'm giving you the derivative and asking you what is the actual function. Now, if you think about this a little bit, you might be smart enough to figure out, hey, I think the function was x cubed. Because if I take the derivative of x cubed, I would get 3x squared. And you would be right. If the function was x cubed, then the derivative would be 3x squared. Now, what's interesting though, gentlemen, is this is not the only answer to this question. There are many functions that the derivative would end up being 3x squared. So for example, if f of x is equal to x cubed, the derivative is 3x squared. But if f of x was equal to x cubed plus 8, the derivative of that would have been 3x squared. If f of x was equal to x cubed minus 32, the derivative of that would have been 3x squared. If f of x was equal to x cubed and we put any constant out here, that constant could have been 8, could have been minus 32, could have been 0, could have been 17. As long as it's just a number, the derivative of this function would be 3x squared. So when you're taking an antiderivative, what really gets interesting is there are an infinite number of possible answers. Now, this is how we're going to write our answer in order to take that into account. We're going to write the answer as x cubed plus, we're going to use a capital C to represent the constant. We don't know what that constant is. It might have been 0, like as in this first example. It might have been 8. It might have been negative 32. It could have been any number. But if our function is x cubed plus any constant, the derivative would end up being 3x squared. So today we're going to take antiderivatives. So in order to do this, the first thing we might be asking ourselves is, well, let's go over again how I actually take a derivative. So if I give you some kind of function and I say, all right, hey, f of x is equal to 10x to the fourth, and I say, all right, take the derivative of that, you guys would sit here and you'd say, all right, let's see, f prime of x equals, and you would take the 4 and you'd put it out front, you'd multiply it by the 4, and then you would subtract 1 from the exponent. You would say the answer to this is 40x cubed, and you would be right. And so what you actually did is you multiplied by the exponent. That's step 1. And then step 2 is you took the exponent and you subtracted 1 from it, right? So we took the 4 right here and we brought it out front, and then we subtracted 1 from the exponent. That's the process we take when we take a derivative. So if I'm going to do the antiderivative, I'm going to do a very similar process, but I'm going to do it in the opposite direction. Okay, so here's how we're going to take an antiderivative. We're going to take these two steps up here and we're going to do the opposite, and we're even going to do it in the opposite direction. So the last step in taking a derivative was we subtracted 1 by the exponent. Doing an antiderivative, we're going to take the exponent and we're going to add 1. And then the first thing we do on taking a derivative is we multiply by the exponent. That's going to be our second step down here, and we're not going to multiply, we're going to divide. So An antiderivative has the same two steps except they're opposite and they're in the opposite order. So if I told you that f prime of x is equal to 40x cubed, and I said, hey, what is f of x? You would say, all right, I need to add 1 to the exponent. So you'd say, all right, x to the fourth. I just added 1 to the exponent. And then I divide by the exponent. So I need to divide this thing by 4. And I would get 10x cubed is what f of x is equal to. Now, gentlemen, I got to remember one thing, right? There's an infinite number of answers because there also could be any constant out here. In this case here, my constant was 0. But again, if you want to check, let's take the derivative of this just to make sure we did it right. F prime of x would equal, I goofed. This is so hard when you're recording. Where is my mouse? So f of x would equal 10 x to the fourth. But now also remember, there's an infinite number of possibilities. It would actually be 10x to the fourth plus some unknown constant. That constant might be 0, but it could be anything. Let's check to see if I took that antiderivative correctly. I can always take the derivative and see if I got the same answer. So let's see, it'd be 4 times 10 would be 40, and subtract 1, I get 40x to the third, and the derivative of a constant would be 0, so that just disappears. Yep, I'm back to what I started with right up here. I did a correct antiderivative. So when we take an antiderivative, we're going to add 1 to the exponent, and then we're going to divide by the exponent. Those are the steps that we're going to take whenever we take an antiderivative. So let's keep those up there. You might want to put those in your notes. We're going to do some practice here, and we're going to try to take some antiderivatives. So first off, I want to go over a little bit of signage as well. So we're going to actually use this thing here. That's our integration symbol. And if I'm going, that tells you that we're going to actually do an antiderivative. Okay. And here I am. It's also called integration. So we're actually doing integration. So when you guys are actually doing your WebAssign, you're going to be asked to do the indefinite integral. You're going to be asked to do integration. Okay, it's the same thing as an antiderivative. So if I have a problem and I'm being asked to say, all right, let's find the integration of 3x squared. Okay, so I'm going to take the same process here. I'm going to look at my exponent. I've got a 2. I'm going to add 1 to the exponent, and so I've got x cubed. And then I have to divide by that exponent. So I had a 3 right there. I need to divide by 3. And then remember, I always got to put this c out here. So the answer to this problem is x cubed plus c is the antiderivative of 3x squared dx. Let's check. If I took the derivative of x cubed plus c, I would get 3x squared, and this c would disappear if it was a constant. I've got a correct answer there. Let's try another one. So guys, what we're going to do right now is I'm just going to keep trying different problems as we do this. Keep in mind, I'm going to be available out on Teams, Microsoft Teams. So if you've got a question, you can always come out and talk to me if you're having some problems. So here we are. We're going to do another indefinite integration. We're going to take the antiderivative. So let's suppose the antiderivative that I'm trying to take is 20x to the fourth. All right. Step is I need to add 1 to the exponent. So I got 20x to the fifth. And I need to divide by that exponent. So I'm going to divide by 5, and I always got to remember that c out there. That's an easy thing to forget. So 20 divided by 5 would be 4. I got 4x to the 5th plus c. If you're not sure if that's right, take the derivative of 4x to the 5th plus c, and you would get 20x to the 4th, which is exactly what I started with. So you can always check your answer by taking the derivative and seeing if you've got it. Let's do another one. Let's suppose I want to integrate the following. 5x squared plus 3x plus 7. Now, gentlemen, I would imagine some of you guys might be asking, hey, Mr. Bender, why in the world are these dx's appearing here? Why are they there? I'm hoping you guys remember that when we took the derivative, let's say our equation was y equals 4x squared. When we took the derivative, what we really get is 8x dx, and the derivative of y is dy. And so these dx's and dy's are really here. When we're going to do the opposite, the dx is there to begin with. And we're not going to do this yet, but ultimately, guys, what I'm going to be asking you to do is whenever we integrate, we have to integrate on both sides of the equation. And when we do that, what we're going to end up with in this case would be y equals 4x squared. Of course, we might have a c there that was originally 0. All right. So, gentlemen, that's why that dx is being there. So let's try this again on this guy here. So let's see, I've got 5x squared. Well, the first thing I do is I add 1 to the exponent, and then I divide by the exponent. Step 3x. Let's see, what's the exponent here? It's really an x to the first, isn't it? So this is actually going to be 3x squared, and I divide by that too. And then what's the exponent here on this? That's a tricky one right there because I don't see the x, but there actually is an exponent right there, gentlemen. It's actually an x to the 0 is what we've got right there, because x to the 0 is just a 1. So what I end up with is, let's see, I add 1 to the exponent, so I'd have 7x to the first, and I divide by 1. And then don't forget that c out there. So this guy here ended up being 5/3 x cubed plus 3/2 x squared plus 7x plus c is our answer for that guy right there. Well, what if I end up with something that looks a heck of a lot more complicated? What if I've got something that looks really ugly and it looks like this? I'm being asked to integrate the square root of x dx. Oh my goodness. I have no idea how to do this one. This is way more complicated. Well, the key here is we're going to rewrite. We're going to rewrite this problem. So what would be another way I could write the square root of x? I could write the square root of x is x to the 1/2. Now that I can work with, because I know how to take the antiderivatives of things with powers. We add 1 to the exponent, so a half plus 1 would be 3/2, and then I divide by the exponent. So I divide by 3/2, and I don't forget that c out there. And so in this case here, dividing by 3/2 is the same as multiplying by 2/3. And so I've got x 2/3 x to the 3/2 plus c. I know that's an ugly looking equation, but gentlemen, what's important to realize is I'm doing the exact same process. I'm adding 1 to the exponent and dividing by the exponent. Even if my exponents are ugly looking, it's still the same game. So what about this one here? Suppose you're being asked to integrate 1 over x to the 4th. Oh my goodness, there's no way I can do that unless I rewrite it. So what if I rewrite that guy as x to the -4 dx? Now I can work with it. I'm going to add 1 to the exponent. So -4 plus 1 is -3. And I divide by that exponent. And of course, don't forget the c out there. So this guy ends up being -1/3 x to the -3 plus c is my answer. If you want, we can take the derivative of that, and let's just check. Let's take the derivative of it. So if I took the derivative of that, right, it would be, I would take the exponent and multiply it, and then I would subtract 1 from the exponent, and the c would disappear, and you could see I end up with 1 x to the minus 4th, which is exactly what we had right here in the beginning. So this will always work, gentlemen. We just sometimes have to rewrite the problem to get it into a form that we can work with. So I'm going to do one more here, guys, before I let you go. So let's say the integration this time is x times x to the 5th plus x dx. Let's say I'm trying to do this one. Well, again, I'm going to suggest let's rewrite it into a form we can handle. I could distribute this x, and I could rewrite this as an x to the 6th plus an x squared dx. And now I've got one I can handle. So I add 1 to the exponent, and I divide by the exponent. I add 1 to the exponent, and I divide. Whoop. I divide by the exponent. And don't forget that constant out there. So this guy ends up being a 1/7 x to the 7th plus a 1/3 x cubed plus a c. So gentlemen, hopefully that's enough example problems for you guys to be able to do the homework. But again, keep in mind, I'm out on Microsoft Teams during class time. So if you're having some problems, please join the meeting and ask me for some help. I wish you the best of luck. There's some problems on a WebAssign for you to try, and let me know what I can do for you. I will talk to you later.